So I'm going to talk about lesson learned from the design of the SCIM API. It's going to be a pretty technical session, so if you are afraid of HTTP headers, I think it's some kind of business session over on the other place, but it's not going to be a lot of technical stuff, but a bit. So brace yourself. As we said, my name is Eric. I work as a technology strategist at Nexus. Nexus is a Swedish company, and our headquarters is just here in Marievik. We work with identity and access management and PKI, and we develop software that our customers use. That's usually banks and enterprises and Swedish kommuner or municipalities. I'm one of the authors of this SCIM specification that we're going to have a bit of a talk about. So 3 things that we're going to talk about today. What is SCIM? Why does it exist? What problems does it really solve? And then we're getting to the interesting stuff, I guess. What kind of lessons did we learn, and what kind of design decisions have we taken, and why? So System for Cross-Domain Identity Management. It had an earlier name in the beginning, Simple Cloud Identity Management, but that's now gone, and it now stands for System for Cross-Domain Identity Management. Here is the new logo. We've been working on this for, 2.5 years now, and we got the logo last week, so I just uploaded it to our website. So, very happy with that. So, enterprises, they are kind of distributed. They're not like mainframes anymore that people have all their data with and everything under control. So the IT environments have been changing a lot, as you guys already know. That means that you have your applications and your data like sent over all over the place on cloud services, on internal systems, on partner systems, and pretty quickly you lose control of where your data is and why it's there and why it's not removed and so forth. So that's not really fly when we're talking about identities, because that's pretty secret stuff. Like it's like laws and regulations that tell you how you should handle identity data in a lot of countries. And when you have like a scattered IT environment, like most corporations do nowadays, you have to start getting back control of your data again. So the world kind of needed a standard. How is this done? There's nothing new. It has been done for a lot of years in different ways, and there's a bunch of APIs trying to do this, so this is just like a way to have one API instead of many. And it is a standard, as I said, for lifecycle management. It's like create, update, and most importantly, I think, delete identity data. So you have identities in your Active Directory or at home in your corporation, and you want to send it to a partner, or you want to send it to other internal systems or to cloud providers. SCIM is a standard that helps you do that. The standard is being under IETF, which is an organ that develops standards and specifications. Like most of the internet is built on top of standard developed by IETF. And if we have a bit of a deeper look on what it actually does, so it's a lightweight provisioning protocol. As I said, create, update, delete, take control of your information. And it's actually just 2 things. One is a schema. This is a user. This is a group. This is a machine or whatever. So it defines exactly how those entities looks like or resources looks like. And then it's the fun part. It's the protocol. Okay, you have your user. How do you send it to different systems? So it's only 2 things. It's been developed by Salesforce, Google, Cisco, Unbound, Ping Identity is here. We at Nexus are pretty committed to this. Microsoft just joined a couple of months ago. So it's starting to get a bit of attraction, and it's also pretty exciting because there's these hype curves when it comes to EIM. SCIM just popped up on that, so it's pretty exciting times. So the SCIM players, who is involved? Who want to send data and who stores data? Well, there's only two players involved here in SCIM. It's one system that either have a user that they want to create in some kind of system, or they want to read user or group or identity information in general. And then we have the system that stores them. So it's not so complex. It's like two systems want to talk to each other. But the thing is with SCIM is that, as I said, it's really valuable data that we send. And in Sweden we have PUL, personuppgiftslagen, that defines that you cannot send identity data how you want. You have to have control of what you do. And in Germany, to send user information, like that's personally identifiable information to different servers, you have to have a user consent every time you do it. So you have a lot of different regulations. So between those two systems, it has to be a real high level of trust. SCIM doesn't really talk about that. SCIM don't go down that rabbit hole. SCIM just say like, okay, you've established some kind of trust, good. Now we can start exchanging identity information. So the different use cases that we use SCIM for is synchronization. You have an HR manager, and you have like a new employee at the corporation, and it starts in the corporation, and the HR manager add it to your user storage. And your HR manager do not really want to like create it in all the different cloud systems and all the different internal systems. They want to do it once. And when they've done that, they want to have like it automatically synchronized between the different systems. And I said create, but removal is much, it's even more important. Another way you can use it is on-demand provisioning. And that means that if you have, for example, Salesforce, so your corporation uses Salesforce, you pay a lot of money for each account that you have. And maybe you don't want to like create users in Salesforce and have them there costing money if the user is not really using it. So SCIM helps you like the first time the user want to use Salesforce, the user is created, and when the user quits, that user is removed. So it costs less money for the enterprises, and you take back control. And then it's getting even more interesting, in my opinion. So if you have synchronized the users to a cloud provider, Google Apps, for example, and all of a sudden you want to move to Office 365, how do you do that? Well, today there doesn't really exist a way to do that. You have to like export and import, but with the help of SCIM, the plan is that all providers should support SCIM. Then we could easily like move this type of information between the different systems, and that opens up a whole new exciting world, because maybe your corporation want to like change provider every day. I don't know. You want to change to other systems, and with the help of SCIM, you can like move this information around easily. So as I said, there's nothing new. Has been done for a lot of times. All of these companies that I mentioned all have their own API today. What SCIM does is like defining one standard that everybody could use. So we have developed provisioning plugins for all of these different providers, and it's like a whole market in developing these kind of provisioning plugins. The meaning with SCIM is that you shouldn't have to do that. You should just have support for one system. There's also been earlier attempts in doing this, called SPML, another standard, but that didn't really work. It was like a SOAP-based thing that didn't define a schema. This is a user. And that meant that every time you wanted to send it to different systems, systems didn't really understand what it looked like. Like, what did I get? Some kind of something, I don't know. So it didn't really work out, even though it was a good standard. So it was too complex. And the final slide for defining what SCIM is and why it exists is Why are we committed to SCIM? Well, we have a lot of companies using our products and controlling their identities, and we want to give our customers the ability to like take back control of their identities, like own their own data. And we also do single sign-on, and it's an important step in like before you enter a new system, you should be automatically created. You shouldn't like have to register everywhere. So SCIM solves that. And it's also really exciting for me because like important step for the cloud, I think. Like move between different systems and taking back control of your identity it's an important part in building like the identity layer of internet. So now the details come, so be afraid. We're going to talk about the schema really quickly. So SCIM defines like an empty container, like this is the resource. You can create your own types of resources, but SCIM only defines two. It's like this is a user and this is a group. And that's all the SCIM really defines. Then we really made a lot of effort in making it extendable, because a user doesn't really look exactly the same in all corporations, so it has to be extended. And in the core specification, we have an enterprise user, like works in this, have this manager or whatever. So we define that in the enterprise user. And then we have like a weird meta thing going here, because we have a schema that defines the schemas. So it helps you to figure out when you talk to two different systems, hey, what kind of resources do you support and how do they look like? So we have a schema that defines the schemas, and then we have a small schema that defines like a server has this and that capabilities. Can you create users? Can you search for users? Can you filter users? And that is what the schema defines, and this is what changed between SPML and SCIM. And I know you guys, most of you developers have been longing for this. This is an example of a user, just a JSON document. We don't have to go into details about it, but like you have a name, a username, an email address, nothing new here. Then we have the API, and that's what this conference is all about. So it's a REST-based API. Like take this user and send it to different systems using REST. We tried to make it curl-friendly, because when you have like different enterprises talking to each other, it's pretty hard to like phone up Microsoft and asking them, how does it really look like? So it has to be easy to like test from command line, get a user, how does it look like? You don't want to like program everything to have a go for an API. And when I talk about enterprises and moving data from internal systems to external systems, you're going to have a firewall, and you're going to have like proxies somewhere. And REST-based APIs can be proxied through these firewalls and proxies. Like HTTP is the perfect open up the whole world through port 80 or 443. So it's pretty good ports, powerful ports. SCIM doesn't really define an authentication method. As I said, like the trust between these two different systems. We don't talk about so much. OAuth2 is recommended. You could use certificates if you want to. And encryption of this data when it's sent over the internet. Good thing. You want to do that. Because, as I said, valuable data. So, how does this API look like? Well, the core schema talks about, the core API talks about 5 different endpoints. /users is where you create and update and reads user. /groups, it's the same thing for groups. Then we have the service provider config, an endpoint that can tell you, hey, new server, what kind of capabilities do you have? Do you support the bulk transfer thing? Schemas defines what resources a specific system supports. And then we have this bulk thing that's good for, okay, I want to move everything from this server to another server. You don't want to do that in single requests. So bulk is a way to like package a lot of requests into one huge HTTP request and just send it. When we talk about the verbs here, get, someone will guess what that is, but it's like get a user from the server, post creates a user, put replaces a user, patch, it's like a special thing there, but it's like updates the user. If you have a huge group of all of your employees, you don't want to like replace it every time you add a new user. You just want to add one specific user there. And delete removes the user. So here is where the HTTP headers comes in. So in top there, you can see that we send a post to the user's endpoint. And that means that we want to create a user. And this is an example user that you want to create. Back, you get an HTTP 201 saying, yay, this user was created successfully. And the server added some things. You can see that it added both an ID and some meta information here. And the ID is like unique. So every time you want to get that user that you created in Google Apps or Salesforce or whatever, you can find it under that URL. And you can also have like a permalink. I don't know how you pronounce that in English, but permalink, something, I don't know. From now on, where are you going to find this user information? And the ID is the same in the URL there. So that's added by the server. Get against that same URL will return the same user, of course, with a 200 OK. Of course, there's other features there also. If you want to look at more at the specification, you can do that. But if you have like millions of users, you want to make sure that you can filter them and paging and sorting and stuff like that. And we also have the discovery functions. How do you act, or what features do you have? So now you're experts in SCIM. That's good. Some of the lessons learned. Well, when we developed this standard, how you like move users, it has been really important for us to follow the 80-20 rule. Like, we do not want to support all the different functions in the world, because when a lot of enterprises are going to talk to each other, it's not really going to work out really good, because everybody is going to have their own little tweaks, and that's going to make the API unuseful. So an early design decision was to like only support the most common 80% of the features. And that really helped us in being able to deliver something at all. Because like you have to know what your common case and what your corner case is. Because corner cases are like really confusing. So like 80 confusing %. Because it's going to be hard to implement them. It's going to be hard to understand them. And most of the cost in like developing and understanding and supporting an API comes here. So this is where it's starting to get expensive to understand and implement an API. So for example, the SCIM user there, it's going to be hard to like define exactly what is the user. So we've been working a lot with extensibility here. And this is an example how we add the enterprise user. And like we also we define that this user is both a core user and has this enterprise thing going. And here you can see that it's added to this user. An early design decision was also to like use versioning a lot. So we have like versioning of the API in the URL. We have versioning of the schemas. Every time like you update the schema in a version, that's supported. And we even have versioning on a specific resource. Like, this was you last day, then you got married and changed your name. Now you have a new version of you, I guess. And so we had a lot of discussions of, are we going to send the version of the API in a header, or are we going to have it in like an URL? And we opted for the URL one. And that's because we wanted to have this permalink. Like, you can always find a user here. And it's also like easier to understand for implementers. It's like, it's a new version. So if you make an HTTP request against this system, it doesn't really act in a way like this system. So took a lot of discussions, but that's where we ended up. Schema, we already mentioned a bit. But versioning of the users. How many is familiar with Etags? Some of you, good. How many are familiar with weak Etags? Some of them, good. So Etags is really, really used a lot in the web world. Like, your browser doesn't really always have to ask the system if you already has the latest version. So in SCIM, we like use the HTTP function of etag, like, this is the version of this specific file. We named it version in SCIM because we want to be able to send these SCIM users through SAML and through other type of XMPP or whatever. But we make a lot of use of Etags, and weak Etags is like, if you have a new developer that's coming fresh from university at your corporation, and it like finds a new version of the JSON parser, and they're probably thinking like, oh, it has the same functionality, so I'm going to use the new one. All your unit tests go through, everything is fine. But what actually would have happened is maybe two different attributes changed place. Your unit test didn't really find that, but the data is still the same, but the etag would have been changed. So that's why we use something called weak etags. Like, it is still the same data. All your other systems don't have to get new versions of the data because it's the same data, but it's just different formatting of it. We're really tedious in defining error codes. So ever got like 400 bad request or 500 internal server error, it doesn't really help you. And we have like enterprises here, other corporations here. It's pretty hard to phone up people and ask what kind of error did it end up to be. So we're doing both a human readable and a computer readable error code. I don't know which one you like best. I like this one. I kind of understand it, but we have like defined good error codes that we use. It is in the specification. We also use something called HTTP method overloading. Firewalls and proxies, some of them doesn't really like all verbs. I don't even like all verbs because I've always had a hard time figuring out what that is. I like vowels and stuff also, but verbs is never traversed in a good way over internet. So most servers and client APIs, some servers and client APIs don't support delete, don't support the patch thing, because that's not even part of HTTP. So what we do then is like make a post, but we send an HTTP method override and say it's really a delete I'm doing here. So this is an important step to like make requests to different systems. Well, we made the release pretty quick of first version of SCIM. I think it took like 9 months in developing it. Version 1.1 took 4 months. And then we got some implementations going. And because it's pretty important when you develop a standard that you have different corporations implemented the standard. So getting a release out early, like this is version 1.1, was pretty good. And then we moved everything into IETF. Then we have a lot of more eyes at it. So we've been working on it for like 1.5 years. for version 2.0. And the things we've figured out after doing all the interops tests and stuff, it like we needed some kind of references of resources. So Microsoft has something called Graph API that does kind of like this, but it can traverse graphs. SCIM 2.0 added a feature of like adding references to other systems. So you have like a group, so you can find out the reference to a user in the group. You can find out the manager of that group. So traversing a graph with your representations of whatever you send is pretty important. Search using post, it's also an important thing, because if you do a get, everything is saved in HTTP logs everywhere. And if you have identity data, that's pretty secret. So what we did was added a method of searching with post in 2.0. That's going to become a standard soon, like half a year or something. In the beginning, we had both XML and JSON. IETF is pretty funny because it's not really a vote of something. Everybody hum instead. So it's a big room of developers. And we said like, okay, how many want JSON? People like, How many want XML? Nothing. So that was pretty interesting, because I thought that enterprises want XML, but obviously they don't. So in 1.0, XML was mandatory to implement. 1.1, optional. 2.0, dropped. Next thing is that we're working on integrations with OpenID Connect and SAML. How do you like send a user with SAML, and how does SCIM interop with OpenID Connect? So this is what we're working on right now. If you want some more info, you can have a look at simplecloud.info. It tells you everything about the standard and the API, and it also have like an you can run tests against your own systems if you want to develop against it. The work is done under IETF. You can have a look there, or ask me questions if you want to.
Sorry, I have to disappoint you, but I have a question regarding JSON actually, because I think it's kind of interesting that they drop it also, because I didn't expect that either actually. Because I mean, usually the argument for keeping XML is the schema capability, yeah. Right? So how was that solved? I mean,
yeah, because it really helped us in the beginning to have a schema, like verifying that everything was correct. But we have our own schema now. It doesn't really has the same capabilities as an XML schema, but we're taking like, this is a date format that you use from XML schema, and yeah, it's a good question, because we seem to it seemed to work without it. So I thought we needed it, but obviously we don't. So, but there is some work on JSON schemas and stuff, but we'll see what happens there.
All right, thanks.
Thanks.
One more. Any more questions? No? Well, thank you very much, Erik.
Thanks.